Oh, yeah. Well, yeah.
I've been instructed Monday morning to start talking.
Oh, yeah, for sure. Monday morning. I figured if I sent you something, then I would think about it. What?
Let's get you on that phone. Coming up.
Oh, yeah. My in-laws are go big beach.
I think the biggest thing
Yeah.
will be cold because it is snow.
I was in Boston for years.
I mean, they'll have
I woke up at 6 a.m.
it's mainly for life.
Couldn't go back to sleep. Because I see lacrosse gets a foot, and I'm just like, come on, can we get anything?
I saw it.
Okay. It is about time to get started, if everybody's ready. Welcome to Weather Watch. It's been a very busy week, at least for us, and a lot of people across the U.S., if anybody's been paying attention to all of the weather that's been going on. I will come back to this in just a moment, because I want to start out a little differently, first off. And yes, thank you. These are the daily highs and lows for Madison from about the start of February to now. Just looking at things, going through it all this morning, I was joking with Flora, to quote Dinah Washington, what a difference a day makes. We began the week and this weekend, if you're outside for Valentine's Day or any point over the weekend, we had a high of about 64. We set daily high temperature records on the 13th, the 14th, and the 16th. The 16th breaking the high record by 7 degrees. So not a small feat. And I hope you all enjoyed it, because if you've been outside today, we've been on a steady decline to now where it's very snowy and very, very windy. It's kind of hard to walk to the building today. I don't know if anybody else experienced that. We'll look more at that here in a second, but we can go back to the satellite loop for now. I just wanted to point out we've been on quite the roller coaster, temperature-wise, for the past week. Is this the week-long?
It is.
Okay.
Not too long.
No, that's perfect. So yeah, this is the week-long satellite. It's been very busy for especially the eastern half of the U.S. That first band of storms that kind of moved through produced pretty severe weather for the people in the south. We can look at the storm reports for that here in a second. But we've also had a good amount of storms for us here as well. As this restarts, I will point things out as we go along. So around Valentine's Day into the 15th here, we can look at storm reports. But this little cyclone and this band of really big storms produced a lot of hail reports, and I believe a few tornado reports as well. We can double check that here in a minute. But eventually, it moved out and off the coast. I believe, what was Tuesday night? The 16th or the 17th?
17th.
17th?
Well, and 18th, 0 would be after 6 p.m. So.
Yeah. I believe it is these. Tuesday night into Wednesday. I don't know if anybody else saw this or was woken up by it like I was, but we had a small band of storms roll through, but they weren't inconsequential. There was some pretty loud thunder at 3 a.m., if anybody else heard that happen. It definitely woke me up a couple times. Definitely unexpected in the middle of February, right? For us to get just a one-off thunderstorm roll through at 3 in the morning. Kind of strange, but still fun nonetheless if you're like me and have missed the sound of thunder and regular rain on your windows. And then if we keep going, I can let this play through. We can see what's brought us our big temperature changes and all of the precipitation we've seen yesterday and into today. The storm moved off. We go back to the end of the loop, or we can just watch it go through. Several one-off storms off the coast of Lake Labrador, Newfoundland. Flora said the flights ended on the 18th, but there have been a couple good ones go through. I don't know if have there been good flights before then?
Yeah.
Yeah, some really good ones stepping through.
Just want to mention, since John is not here, look at the scale. of this mid-latitude cyclone that goes from all the way here.
Please.
When have you ever
We
seen
can't
a
escape.
hurricane? Don't get me wrong, I love
If you
hurricanes.
zoom in, if you zoom
I
in.
love hurricanes, but since John's not here, I
But they're
just
two
have to-
separate features.
No, can't keep it over. Anyways,
So yeah, if we stop this once we get closer to the end of the loop, so like last night to this morning, we had a bunch of rain, which I think turned into mixed precipitation, which eventually turned into all of the snow that we got this morning. I don't think it's still snowing. Has anyone been outside?
It was snowing like 20 minutes ago,
Okay, it is still snowing.
but not now.
Okay, so judging from the satellite, a few snowstorms kind of lingering around, enough to be annoying when it blows in your face when it's really, really windy outside. But we didn't get much in way of accumulation. I think I had maybe a little bit of a dusting outside my apartment.
have the official state climatologist report from Ed Hopkins in Fitchburg. He said, we have just enough snow to track a cat here in Fitchburg. He said he saw 8 to 9 inches fell this morning in Vernon and northern Crawford counties, which is just west of us, so I guess we dodged a bullet.
Wow, dang.
It was a real thin strip of really heavy snow.
Yeah.
So,
So we're in the clear. But lots to come for people in the East, which I will not talk about, but Professor Morgan will. Okay. With all of this going on, can we look at the current station observations? Just to check in, see what's up.
surface,
Yes, please. And then we can zoom in on us. We can play everyone's favorite game, guess where the low is, because it's pretty easy to tell just by looking at this. Right about there, right? This low. Everyone in kind of the Midwest area covered in clouds, a few snow reports still lingering around in Michigan, and for us, several north of here in the UP. Along with that, we have our northerly northwesterly winds bringing in the much lower high temperature that we're going to see today as compared to the past few days. But the influences of this cyclone, as we kind of check it out from here, and then as we'll see in some other maps, stretch all the way to the kind of east coast, and then depending on what kind of surface maps you looked at, the Weather Service drew in the occlusion, and the front sweeps all the way down from the Gulf of Mexico all the way up, influences to up into Maine. So this is not a small storm by any means. We've got influences over nearly the entire eastern half of the U.S. We are on the tail end of things. The storm is slowly making its way out east, out of our way. So after today is over, for us anyway, we should hopefully see chillier temperatures, which I'll take, I suppose, compared to a lot more snow.
What's really neat about this map is, I mean, you can see down in the southeast United States, the cold front associated with this, it's already cleared through, I guess, Atlanta, just south of Atlanta, into approaching southwestern Georgia. There's at 74 over 70. Dew points in mid-February in the low 70s, which is just pretty incredible. And then you go up into the Carolinas, temperatures approaching 80 degrees, even with the pending frontal passage. So pretty warm over the southeast. That's going to play a role again in the future weather for the East Coast in just the next 60 hours.
Yeah.
talking about that in Georgia, I'm trying to find it here. John Knox posted on Facebook, the overnight low in Athens was 65. Their normal low is 38, and their normal
Jeez.
high is 60. So then their low was 5 degrees above their normal high. And the record high minimum temperature for this date was 57.
Oh, they shattered.
So they,
Yeah,
they
yeah,
shattered
they've got
the high last weekend.
It's warm.
Yeah.
Yeah. Jeez. So yeah, a lot going on the East Coast. Stay tuned for the forecast. There will be even more going on. The rest of the U.S., though, things are pretty mellow. Not too bad. A few scattered spots of clouds here and there, especially in the Pacific Northwest. But otherwise, people have relatively calmer winds. The expected temperatures for about this time of year, nothing exuberantly warm unless you're in the southeast. But still fun to keep an eye on. It's fun to notice if you're doing the weather challenge, our forecast station is Flagstaff. a rare moment where it's not absolutely dumping snow on them right now, which has been very hard to forecast. If you're in Weather Challenge, you know what I mean. It's getting really old, really fast. But those are the main things going on right now.
They got spring training baseball starting there tomorrow too.
Oh, really?
And not Flagstaff necessarily, but in the Phoenix area.
Good to know. Keep an eye on it for that. It might be snowy spring training.
Cold day for baseball.
Okay, we can look at the radar to see just where it's still precipitating, how much of those cloud covers are still present. And yeah, it's pretty easy to see where that cold front is still kind of moving through and hanging out over the U.S., even in just the radar. The influences of our storm hanging out right about here, and it reaches all the way down into the Gulf. So a weather maker for everybody. Not a lot on radar in our area, which means probably that if it is still snowing outside, it's in the lower levels, and maybe as this keeps moving eastward, it'll kind of taper off and will be mostly free of snow, maybe by the late afternoon. Otherwise, like we saw in the station plots, not a lot going on in the rest of the United States. A few kind of scattered blips here and there. They might be light rain. I did notice a couple light rain or the mist station plot symbols in a few of them. But most of the U.S. is pretty quiet right now if you're not in the East Coast. But they weren't that way earlier this week. Could we? I'm sorry I didn't have you pull this up earlier, but could we check the SPC storm reports? It's been a very stormy week in the South, if you haven't noticed. But once we get storm reports pulled up, we can start the 14th, please. With what was a pretty warm day for us, was not a fun Valentine's Day for anybody down in South. So like that storm system we saw in the satellite imagery that kind of bubbled up over the day of Valentine's Day and a little bit into the 15th. Very rough day if you lived in Louisiana and Mississippi. Several high wind reports, a couple, they're kind of hidden behind all of the other reports, but these big blocks mean high wind reports, so over 65 knots, which is a lot, and then scattered amongst them, 43 different tornado reports, all within the span of one day. So not a fun time for those in the South. And then if we'll be able to move forward, I think a couple days, on the 19th, we can see, this was yesterday. If anyone was paying attention to the weather yesterday, when we were starting to get all of the beginnings of rain, which eventually turned into ice, we were on the top half of the major storms. Everyone in Illinois into Indiana got the most severe parts of the storms, which if you looked at the SPC outlook yesterday, they kind of hit it right on the money. They had I believe it's an enhanced, whichever one the orange is. I always get them mixed up. Yeah, enhanced, focused right in the center of Illinois, and that's where we got tornadoes, large hail reports, and plenty of windstorms all within where the SPC kind of nailed it. So shout out the SPC. But other than that, there hasn't been a lot going on, right? With that, everything that's been going on, we can look at the Pacific satellite just to see if maybe there's anything out there heading our way within the coming week.
You want the whole week or just short term?
Can I just have 12 hours?
This might be 6.
Okay, that's okay. Whichever one works. So this is Pacific. Orient yourself. Hawaii is right about here. It's also, there is one major storm kind of wrapping in up on itself. You can see that as it gets swirly in the middle, which is always, I think, is pretty cool to watch. But it is hanging out kind of west of Hawaii. Some of its cloud influences reaching up all the way into Alaska. It doesn't show up too much here, but you can see the swirlings of what is a low sitting just off the Gulf of Alaska, kind of just hanging out. It'll show up better when we look at the super peat maps. But other than that, not a whole lot of convection present in the ITCZ, which we've seen kind of a lot lately. And then, in the terms of major storms, unless this develops into something, and I have not looked at any of the forecasts, so I will leave that up to Professor Morgan, not too much in the Pacific that would head our way to be a major weather maker. You can see a good view here of these things that look like unmoving clouds. It's just all of the cold air that is trapped in Canada. Cold enough so that it shows up on satellite. But other than that,
Yeah, I
Not
think
too
the
much
big thing
happening.
about the cyclone that was off of Alaska is, as John would point out, is you can see the enhancement, IR enhancement. The blue areas are really indicate really tall but small cumuliform clouds that are forming because of the instability, so really cold air aloft in that broad region, so organized convection there. And then downstream of it, with this broad circulation, you're going to be seeing the development of a significant ridge. It's not evident on this map, not really, but downstream of it, just Rossby wave growth over the west coast of the United States. And that'll play a role also in weather over us on the east coast in the next 60 hours.
Yeah, it's definitely something to keep an eye on. But yeah, even the clouds that aren't high enough to be highlighted in blue, you can still see all the kind of little cells, almost popcorny like clouds forming off of that cyclone. But, okay, with that, can we go to the super Peats, please? A quick tour of the super Peats to kind of give us an idea of what's going on in all the layers of the atmosphere before I turn it over to Michael. Can we start at 250? And we might do some hopping around. So 250, your wind speeds are in this gray to purple shading. Heights in black, temperature red dashed. The biggest thing right now is this absolutely roaring jet over the kind of central to southern United States. This is about 163 knots, which is not insignificant. This is a pretty strong jet stream. Flora and I, earlier in the lab, went on this big investigation of the game. Is this a superposition or just one single really strong jet stream? So if we could go back and hop up to 100, or just 150, sorry. So where I have my pointer right now is where at 250 the center of that jet stream was. Here at a higher level, the center or core of the highest speeds is a little further south of that in Arkansas. And then if we go back again and go down to, let's say 300, that core is still in the center of Missouri where the highest wind speeds was. So if it's not a superposition, they are right next to each other, trying to be probably building off of each other and enhancing that wind speed. There's a product by Andrew Winters that Flora introduced me to that documents whether there is a superposition or if it's a polar jet or a subtropical jet. And this suggested that it's just the two jets kind of right next to each other. No superposition, but them being so close to each other, they're probably helping make those wind speeds really, really high at that level. So, knowing that, we have really strong jet streams. And we saw this, right, back when we looked at the satellite, the clouds over the kind of central U.S. were really zooming, and then the storm systems that move through as well were kind of going through at a pretty quick rate, really fast. All of those as a result of this really, really strong jet stream just kind of hanging out over the southeastern, southern half of the U.S. Let's hop downwards to 500, please. The influences of our jet stream still visible in the winds, still very high winds. We've got both a decent gradient of heights as well as, comparatively to the rest of the map, our best gradient in temperatures compared to most other places in the U.S., which makes sense because that's where our jet stream is at upper levels. But we can kind of see still remnants of what the storm that is currently passing over us heading east is left at upper levels. And then, like I said, I have not looked at the forecast yet, but if we look upstream at things, here's the low that we saw in satellite imagery sitting over the Gulf of Alaska. It's still kind of sitting there. I haven't looked at a forecast, but I'm sure you will talk about where it's coming next. And then there's a little bit of something that is kind of wants to be a trough, it looks like. It might get absorbed into the flow from what I quickly looked at earlier, but like I said, I will leave that to Professor Morgan to talk about.
But that is that one that you just indicated, it doesn't seem particularly impressive, isn't it? Looks like it's the seeds for the big east coast event and stuff.
Yeah, so take note of where that is and for what's to come. Still, storms that we saw earlier in the week have now gone off into the Atlantic, hanging out over there. And then quickly, since that is the main feature going on, we can also hop down to 850. Yeah, here's a much more defined structure of what our cyclone that brought all of our snow today kind of looks like. You can still see, we saw it in the observations and in the radar, but it's also very present here. The structure of this storm in both these kind of little divots in the height lines, as well as this heightened thermal gradient near the storm. So with that, you also notice not as much signal of that low performing disturbance that we saw up at 500 at this level yet. And then the storm up in the Gulf of Alaska is pretty strong. We can also see in the height lines about where its frontal structures might be at, hanging out. And then the storm that's been hanging out off of the coast of Newfoundland is also pretty strong. Its thermal structure also pretty evident up there. So that will definitely be interesting to keep an eye on in the future. But with that, all of our interesting fun weather has kind of moved on for at least the time being. But there's a lot of interesting things to come, which, does anybody have any questions before I turn things over?
Is that guy in the Pacific the same rigid death we've had all season, or is it a new one?
I don't know. I didn't go back that far to see if it moved or what. Do you know?
I'm very correct me if I'm wrong, but I think the line Ian is talking that shim projects that ridge right there. So that would kind of make sense.
That would make sense. I don't
Yeah, I haven't looked at the top connections, but
either.
I know in the last week, we were talking about this last Friday, the western United States, which has been dry, finally got into more of a trough-like pattern, and we got significant precipitation there this past week. I think feet of snow in the mountains, and unfortunately, an avalanche that killed 7 or 8 people.
Whoa.
So the ridge has shifted a little bit. Was it along the west coast or just off the west coast? I can't recall.
Typically when I look at it, it kind of is co-position with the Gulf of Alaska down there.
Good question.
Retrograded a little bit.
Good question. Anybody else before I turn it over? Okay.
Just one comment online, some guy named Patrick Liddy says, "Happy birthday, Liddy."
Thank you, guy online.
Should we say, you said you're going to
Oh,
lead
God.
us in singing, so.
That's okay.
Happy birthday to you.
I don't know what to do.
Happy birthday, dear Liddy. Happy birthday to you.
Thank you. Thank you. I was going to see how long I could go before people asked why I had this on my head. But
Happy birthday, thank you.
the
Thank you. Okay. And hi, Patrick. All right, let's first go to the our normal start. I'll go to our wharf model run, local wharf model run. Before we get to that, we'll go to the wharf model run. And start off with the meteorograms with something special. I removed it finally. Okay. For your birthday, I removed it. So, temperature, dew point's not here. We'll do that in another structure, and then this is just the cumulative precipitation. But the key thing here is, unlike last weekend, which again, the models were well underdid the temperature forecast, surface temperature forecast. We have that somewhat upward trend. This is not the case. We're going downward, getting colder over the course of the weekend. So that's kind of a theme for, I think, the week ahead. Not severe cold, but definitely colder than the last week, which was well above normal. I noticed, Libby, when you're showing the historical meteorogram, as everyone calls it, in that meteorogram, it showed that I guess our average high temperature on the day that it was 64 is like 31. So we were well above normal. So this weekend looks like we're going to be perhaps below normal with some chilly weather, but again, not the severe cold that we saw back in January. And in terms of precip, what we've gotten is pretty much what we're going to get for the next few days as things begin to dry out over us. So let's go out of this, look at the time height section. And it also shows a fairly quiet pattern over us. You can see the closely spaced isotropes. These are the yellow lines here, indicating a nice, strong, stable layer. I guess there is some cyclonic vorticity in our vicinity, coupled with a strong stability, gives us these little sort of PV anomalies in the lower troposphere, likely not diabatically generated, well, not diabatically generated from precipitation at least, but we can see that because we're not getting precipitation, but these are just due to maybe radiative cooling at night, helping to form these stable layers. Vertical motions in the mid and upper troposphere. There are some regions of ascent, periods of ascent that we're going to see over the course of the next few days. This is, I guess, with the outgoing wave that's moving by us, and then tomorrow afternoon, this, and in fact, enough to give us perhaps some high clouds. And in the lower troposphere, it actually stays relatively moist, high relative humidities that don't change much over time, which indicate that there's probably a lot of moisture. The water vapor content in the air is pretty high, and we're probably going to have some mid to low level cloudiness over us. So not the greatest weekend. It'll be chilly. You can also see the isotropes slowly sloping upward over time, which indicates that the lower troposphere is cooling off, right? So that would indicate our thickness is falling over us, and we'll see that it's going to be the case in the forecast when we look at the maps. Let's go to the full surface map. We'll look at the loop, run it through once, and then we'll step through it. We'll be quick about it for the Midwest and focus on what's happening along the East Coast, or may happen along the East Coast. So let's go back to the beginning. There's our surface cyclone, really shows up well. This is from 12Z analysis using the NAM to initialize the model. And you can see strong cold advection to our south, still some warm advection even over the northern parts of our state that helped, that localized warm advection helped to produce some of the snowfall that we had. And if we go ahead 6 hours to right about now, this shows sort of the accumulated precipitation between 12Z and 18Z today, and that's pretty much, I guess, where we have the precipitation. But in that sector just to the north of the cyclone, again, modest precipitation forecast in that region. Over the mid-Atlantic and the southeast, we can see some of the showers and convective precipitation that perhaps we saw on radar earlier. This is the accumulated precipitation over that time period. Then you go to the far southeastern part of the United States, the precipitation that was lined up just ahead of the frontal zone that was moving through there. Out over the southwestern part of the United States, some local showers and precipitation out there. Some of it rain, some perhaps snow in the higher elevations. But again, this past week, last week we were talking about sort of drought conditions there. Some of that's eased a little bit with significant precip in the west. And that looks like, at least in the forecast, likely to continue a little bit. Let's go ahead 12 hours, couple clicks forward. Okay. So that cyclone gradually begins to move out. Still a lot of precipitation lined up all the way from Michigan through Lake Superior into central Canada in this warm sort of trowel-like structure that extends well to the northwest. And a big, sort of burgeoning area of precipitation out of Colorado into Kansas and Nebraska that begins to set up, and we'll look at that. That's just ahead of that trough-like feature that Libby had pointed out earlier. Let's go forward another couple clicks with time. That just fades. Precipitation fades in this region, but you can also see fairly evident in this is a nice thermal trough. We'll look at the potential vorticity structure associated with that and see that it's a fairly impressive trough that's beginning to form. and a lot of precipitation along the little frontal zone that extends from the Atlantic back into the western Gulf of Mexico. So we have surface baroclinicity. Remember, we saw temperatures today approaching 80 degrees in the southeastern part of the United States. Cold advection in the wake of this decaying weather system, so maintaining a nice, strong frontal zone. And we have, at least, we'll see in just a moment, the pieces that are necessary for a cyclone to develop. And some of the questions that are going to come up are, where does it develop? How quickly does it develop? And is there sufficiently a decent amount of cold air? This is not for us, but for the eastern part of the United States, to get perhaps a significant snow or wet snow turning to rain, or even just plain rain event, if it occurs. And a lot of forecast uncertainty associated with that. Rather than continue, let's just step forward a little bit to watch the evolution of this cyclone as things begin to come together. You can see the baroclinicity beginning to tighten up, surface pressure is beginning to fall around 1,009. At this point, this is at 42 hours in the forecast. We can step ahead down to 1,004, 6 hours later, down to about 1,000 hectopascal at 54 hours, and then one more step down to 990. So we lose, about 10 millibars or so of pressure in just the last 6 hours of this forecast. This is a rapidly deepening cyclone just off the mid-Atlantic. And again, for us, I think most of this, we're not going to get actual precipitation here. There's light precipitation forecast by this, but this is maybe the choice of the precipitation parameterization, pretty sensitive, but a lot of low-level moisture over us, and so some cloudiness, but I don't think we're going to get much. It's not going to be a wet weekend for us. But this event, as we can see the nice thermal trough beginning to wrap around this is a really impressively, rapidly developing cyclone. We're going to look a little bit about some predictability issues associated with this. This has the potential to become, frankly, for places that have all snow and really strengthening winds here just along the East Coast, maybe even blizzard conditions developing over New Jersey, maybe Long Island, and the southern part of the Delmarva Peninsula over the weekend. But this is not etched in concrete. Meanwhile, with the amplification of this thermal trough, notice the thermal ridge has at least briefly poked up here, and we'll see that also in the PV field, sort of a downstream wave development across North America. Let's go to the PV maps. We'll start at 305 to, 315 layer? Right here. Let it loop, and then we'll restart it. So as we step through this, just watch how this trough-like feature begins to organize over time. All right, get some amplification here, and there are little pieces of vorticity or potential vorticity that seem to merge with that. But before we go any further, also watch here, this fairly nice ridge downstream of it. It's a ridge in terms of geopotential, it's a trough in terms of PV ahead of it. This is what we'd call a trough, but it's really a PV ridge since it's local maximum. But don't get confused about that, right? Just being specific about the terms here. But upper trough, downstream ridge. Remember, if airtel PV should be conserved in the absence of diabatic heating, like from latent heat release or frictional effects, we're going to see the development of a ridge right over just offshore in this region. You'll watch that because of latent heat release. Some of this might already be, if you go back and click for a second, Pete, some of this is just features that are being advected along, but as we step forward now, slowly in time, if we see anything beginning to grow in this in terms of low PV that begins to emerge, that's strong evidence of diabatic heating. Another click. Okay, see this beginning to form where there's perhaps a warm front. And looking here, downstream of it, if we were to simply advect this, these green values should be moving over parts of New Jersey and eastern Pennsylvania. But if we step ahead, bang, you get this whole, almost a wall of really high values of PV, no PV downstream of it. The advection across this is going to be pretty intense, and so heavy precipitation perhaps is forming here, but also the possibility, or the realization actually, of perhaps strong ascent forming just in this region. We already have a surface cyclone here, so this thing is going to just bomb out over the next, in the subsequent times if we were to let this animation or this forecast move forward. If we let it just run through this loop again, and you can see briefly the beginning of the amplification of a ridge over western North America, it's fairly progressive. That's one thing to note. That's going to be of interest to the forecast. The other is, if we could go back to the surface map at the final time, at 60 hours, that's kind of interesting. Having grown up in the East Coast, this is something that I sort of cringe when I hear things being somewhat overhyped about a major snowstorm. I'm not saying it's not going to happen, but I'm saying we have to be careful. Go to the 60-hour forecast here for a second. Great, we have a cyclone here, heavy precipitation, fairly low thicknesses. But one of the things that's lacking in the forecast, and it's slowly beginning to emerge, but it's not quite there, is in order to keep the precipitation, particularly even in the major cities, but further to the east, all snow, is a huge anticyclone here that can supply the cold air into this developing system. And I look at this, I see warm advection over this entire region. And it just makes me a little bit nervous when significant snow is hyped. The models are forecasting snow, we'll see that in a moment, but we don't have this really cold ridge to keep the cold air in place. Again, we'll see that heights as well as sea level pressures have been rising in the forecast over the last few days, sort of correcting for that, but it's not quite there yet. So that's just one thing. I think that's one fly in the ointment is precipitation type. Will there be significant precipitation? I think that's likely. The deepening seems consistent with the structure, at least of the PV in this forecast. The baroclinicity is there, fairly potent upper trough. All these pieces are coming together, but I think the lack of significant cold air might be the thing that makes this less impressive at the end. So let's now go to the pivotal maps. And I'm going to show you first sort of a tale of two forecasts over the course of the week, or three forecasts. We're going to look at three of them. These are all forecasts that are valid. This is, first of all, total snowfall valid by Tuesday morning. And this is from the ICON model, the German forecast model, initialized 12D on the 18th. And so we're looking at 6 forecast cycles of this every 12 hours. And you can kind of see a lot of uncertainty in this region, eastern part of the United States. Let's change this to the ECMWF. And I'll note that the icons does have some snowfall there, but in terms of like areas in the west of the Chesapeake Bay, does produce a lot of rainfall as opposed to snow. This is ECMWF. Again, you look at this, saying like, what's the deal here? Doesn't seem particularly impressive. Here, there's a band of precipitation that wasn't initially there in the forecast that begins to kind of become more prominent. And then we have our friend, the GFS. And we'll look at that. Again, these are all valid at the same time for total accumulated precipitation. These areas here are approaching 2 feet or in excess of 2 feet. But it's locked into a solution that seems like it's stubbornly holding on to the solution, whereas some of the other models have been gradually approaching this, but nothing quite as intense as this. So there are a few forecasts in this loop that actually show very little snowfall, but then by midweek it's really locked into something that looks fairly significant.
That is the Kuchera snowfall estimate too, not the 10 to 1. Is there a reason
Right.
that you prefer that, or is that just?
I think that accounts for it. Looks at the temperature in the column from 500 hectopascal down to the surface, and it has an algorithm that takes the maximum temperature in that layer to make sort of an adjustment for snowfall.
So
But I think these are
given
all
the pull of
Kuchera.
The warm air off the coast and don't have that ridge to the north, that's maybe a better option.
Yeah, right. So yeah, I'm looking at Kuchera as opposed to just a simple 10 to 1 ratio because, again, this would at least account for some of the warming that we would see if those features were there. But let's get away from just the total snowfall and go to the surface precip. We'll go to this sort of more standard map to begin with, and we'll change the time. Let's go to 60 hours. That's at the end of our sequence. And just look at a loop of, again, these are all forecasts of surface pressure, precipitation, accumulated precipitation type at Sunday 0Z, so this would be 7 p.m. Sunday evening. And this is a forecast, again, initialized on the 17th, which, again, at 18Z. So that's 17th was 3 days ago, so that would be Tuesday, right?
Yes.
Tuesday, Thursday, Friday. Right, okay. So fairly decent cyclone, 998 right off the Virginia Capes. And if we step forward in this, moves out to sea, this is well out to sea. And if you go look at social media, people saying the GFS was kind of goofy with its initial forecast because none of the other models had anything like that. And then as we move forward in time, you see multiple centers in the forecast. And then a day later, it begins to lock into a solution that looks fairly impressive. Right? I mean, that's just intense. And these winds here, again, if this were to be realized and this were all snow, this is, a situation we can actually look at the wind speeds at this, not wind gust, but look at the wind barbs on this for just a second. Temperature and wind barbs. Up, there, down. Okay, 40 knot sustained winds offshore and in the southern Delmarva Peninsula. These are, conditions that with heavy snowfall, which will probably reduce visibility below a quarter of a mile for a certain period of time for over 3 hours and winds near 30 knots. Those are blizzard conditions that would be possible. But the other interesting thing to note here is these temperatures, if we were to run the cursor over this, does it give the temperatures?
This actually is that initial forecast.
This initial, okay, so let's go to the, one of those times. Okay, 0, 0. Okay, really intense cyclone. Again, these temperatures are still just above freezing. In fact, all the way up to, sort of the I-95 from DC to Baltimore and Northeast, temperatures are just going to be just above, at freezing or just above. If we scroll further to the right with this, these are more recent runs of the model, bringing some cold air in. But again, these areas here where the model is actually still saying snowfall is likely. Let's click right here, Cambridge, Maryland, right about there. Let's see, well, this says rain. Okay. That makes a lot of sense, even though for most of the column, if I'm looking at this correctly, this is, we're below freezing for a good fraction of it, but in the lower troposphere, it's warm. That's kind of odd, but if you look at the precipitation type, the accumulated precipitation type at this time, let's get back out of that and go back to the surface map. Type in rate. Up, right there, please. Okay, maybe I wasn't close enough, but that shows snowfall and accumulation. I think there's something goofy with the temperature structure with this cyclone. Go to the final time. Again, this would indicate that over the last 3 hours of this forecast, fairly impressive heavy snow across the Chesapeake Bay and areas to the east of it, and maybe in some of the big cities just to the west. Let's go look at the icon again. We looked at that before. That was a much warmer solution, and we just move forward in time in terms of these are all forecasts valid at the same time, but initialized at earlier time intervals. Nothing, again, broad area of low pressure, and then finally it's hinting at a cyclone that's roughly in the same location that the GFS had, but still it keeps it all liquid precipitation. Even this morning's run keeps it liquid with maybe some mixed precipitation over Virginia. So this is I think really going to be an interesting cyclone. And finally, Eastern WF. Starts out the week with not much at all. The cyclone well to the east and south. And then finally slowly begins to bring forecast a cyclone closer and closer to the coast. But still not the blockbuster storm that's forecast by the other models. This is really going to be, I think, an interesting forecast. You have models that have been consistently, like the GFS, forecasting, again, 1 to 2 foot snowfall totals here of really wet snow, and a really intense cyclone. Other models with the cyclone much further out offshore with this light to moderate precipitation. Still accumulating snowfall, but something that's quite different. If we look at, I think the key difference here is what's happening to the northeast of this cyclone. So let's go to 500 hectopascal. Also, while we're here, I want to do something. What about, let's first, so we're looking, keeping apples to apples comparison, at least in terms of model fields. This is the UW-AOS, valid at 0Z, and let's actually just go to single model time. So we're not bouncing back and forth. And let's go, we're at 60 hours. Right, Jersey Monday. This is ECWF. Let's look at its AI version of this model.
So Michael, this is really interesting because the GFS and the other models had the secondary development near the coast, but the ECMWF
Right.
doesn't. And it's really interesting that there's such a difference that it,
Right, so it could be how the upper trough is modeled, because if you already have significant vortex stretching,
yeah.
vorticity near the coast, and you then can stretch it there, it's gonna lock it in place and have the development there. So, I mean, they've had these broad little spokes of vorticity, inverted troughs that have been extending from the cyclone, different locations. But yeah, where the initial surface cyclone had formed, with a pretty, impressive upper trough coming over it, is gonna be key to what gets latched on and what gets stretched to ultimately develop. But I want to note that a couple of the other models that are becoming of interest to look at are some of the AI-driven models. So this is using the same initial conditions. This has a much broader cyclonic circulation with, minimum and sea level pressure here, but sort of maximum vorticity out to the east, and a sort of a secondary maximum back here closer to the Virginia coast. If we look at the accumulated snowfall for this particular run, I think it does have that. This is just 10-1, so it's not going to do much. It's nothing to get too excited about, right? It's in the, low single digits, a light to moderate snowfall event at this time. If we go forward to the end of the run, let's go to 78 hours, because it's still kind of cranky at this point. It does begin to develop a strip of really impressive snowfall totals from Delaware up to Boston, right? And just for comparison's sake, let's go to the ECWF, just to look at that eventual track of this. ECWF does give, it finally begins to develop the cyclone, but much later. But it also, as it begins to develop, it does leave this strip back over the DC area. GFS, again, just for total snowfall amounts. They're really big amounts. And then finally, we didn't look at the Canadian model. I want to just do that to be somewhat fair. This is just missing those major cities. Kind of going back and forth a lot of different things, but I want to just go back to also that our the AI GFS, which is a relatively new model. Unfortunately, we don't have snowfall there, but let's go back and look at the 10-meter wind and go back to 60 hours. Okay, so both of these AI-driven models, which are using a very similar setup. This is based on the GraphCast model that Google developed, but trained on different data, different setups. Forecasting a cyclone that's a little bit closer to the coast, but with this broad area of low pressure with kind of an elliptically shaped cyclone center, which doesn't look super realistic. That's what the models are, the output from these emulators is giving. And if we were to go back and look at the evolution of these in time for the same forecast time, compare models, let's go to model trend. Here's what we get from earlier in the week. And as we go closer in with time, we can see that there's been sort of a drift broadly in the cyclone center to the northwest, to the north and a little bit to the west, which again, the trend is there for something maybe closer to the coast. And then finally, 500 hectopascal heights. Let's go there. Oh, sorry, and we're going to go from mid-Atlantic, let's go to the continental view. Click on this, that, and the area that I want to focus on, and let's go to GFS first. If we go back to the beginning of the week or earlier in the week, GFS for a couple forecast periods had a bit of an anticyclone up over eastern Canada, but the key thing to notice down here is even in those forecasts with a developing cyclone in this region, there is not much of a ridge being created just immediately downstream of this trough, which would indicate, one, this whole weather system could be a bit more progressive and keep the snowfall totals to be at a minimum. And if we step forward in time as the forecast length gets shorter, you'll notice slowly the beginning of a development of a ridge, actually a little bit further to just downstream of this region. And that could be because of significant latent heat release in this region. But broadly, a ridge begins to appear just downstream of this surface cyclone. So it slows it up, maybe beginning to see slightly higher surface pressures to the north, which would keep some cold air in. No, just a lot of subtle differences in the forecast, but the fact that even at this range of, under, 3 days before this event's supposed to start unfolding, significant differences in where the band of heavy snow is going to set up. It seems like the models are at least beginning to focus it along the eastern part of the East Coast as opposed to the big cities inland until you get up to Boston, which could get clobbered with snowfall. But just a really interesting forecast sort of conundrum as to how this is all going to evolve. And then, interesting questions that I would want to be interested in is if you go back in time, 60 hours back, what are the key places in the forecast that you'd want to have better observations to narrow down the uncertainties in the forecast? And there are lots of tools you can use. You can use an ensemble of forecasts to look at differences and correlations between variables to see what would it take to get a more intense cyclone further to the west. You can use adjoint techniques as well, although they have limitations because of diabatic processes. But this is, I think, a storm that will be studied, particularly if it pans out to become sort of this, a GFS-like solution because of the consistency in the GFS forecast. I would say I'm glad I'm not an official forecaster, but just because you see consistency in a forecast like the GFS, particularly at this shorter range, doesn't mean that the GFS is going to be right. It just means it's hanging on to, the way that analyses are constructed is they use the previous forecast cycle as a first guess, then they throw data onto it, right? So how much of what we're seeing with the GFS stuck in this sort of loop of persistence in giving a deep cyclone just off the mid-Atlantic coast due to its data assimilation, how it handles the data. People look at the ECWF system, not just the model, but its data assimilation system as being sort of first rate because it really captures some very fine details perhaps better, it makes better use of data in its data assimilation system. Could that be why it's kind of sort of lagging behind what the GFS is doing because of how it's using the data? We've had aircraft flights out over the Pacific earlier in the week, I think, to help constrain the forecast uncertainty. Those go both into the GFS and to the ECWF model. So again, I just think this is an interesting, fascinating case of forecast uncertainty that's getting down to the wire with a potentially big impactful storm for populated cities of the East Coast. Do I think there'll be explosive cyclogenesis off the East Coast? I think that's a pretty good bet, but its actual eventual track is going to be problematic. And again, the other factor that I think is lacking is significant cold air to keep it all as snow. I think the models seem to be a little bit too warm in my mind, or sorry, too cold in my mind to keep this as a sustained snowfall. So we'll see how that works out. Again, for us, for the weekend, we can actually go back just to the surface map, GFS, current time, and look at the week's weather after this thing actually is over. So go back to a single image. Oh yeah, and I want to do one last thing. Single image. I'll watch the time. And we can watch this, we can step ahead for a few frames just to watch this develop. Again, notice that sort of broad area of low pressure there, 983, 976. And again, a lot of precip offshore, but pretty tight. But again, no really big, strong anticyclone to the north, which is just surprising for this setup. Okay, but for us, that cold advection persists until we get into maybe past Monday, and then maybe a warm-up begins for us as well. I'd mentioned these AI forecasts, and if we just stop right there as an example and go to the GFS AI, or AI GFS forecast for the same time period. Again, these are models that have been trained using reanalysis data. We have to go to the sea level pressure and wind. They only have, depending on the model you're looking at, just a few dozen levels, vertical levels in the model. Trained on reanalysis data. European Center's doing this operationally. NOAA's begun doing this operationally. What's nice about these models is they can actually produce forecasts that are
as good, if not better, than the operational physics-based models and run it in a very small fraction of the time. To run the GFS out to 16 days, 384 hours on hundreds of processors might take on the order of about 2.5 hours. Running this model, probably about 3 minutes. And you can get an accuracy that's comparable, if not better, by certain measures than the physics-based model. What's nice is these are now being obviously distributed out to the public broadly. Private sector companies now putting them on the web. Pete's begun producing some maps, more specialized maps from these, rather than just simply showing us, a difference or a plot that just shows the these models from a different standpoint, or individual maps. He's beginning to produce some maps that show differences between, in this case, the AI-GFS and the GFS. I think the isotax are the GFS forecast, and the fill pattern are the differences in that, in the
So
isotax
it's the
difference.
GFS wind speed, and then the contours or the color is the AI GFS minus the physics-based GFS.
So you can see
blues
places.
are slower
Mhm.
and reds are faster in the AI GFS versus the GFS.
Right. So it'll be interesting, for this set of maps to begin kind of looking at that, to see differences between the physics-based models and the AI sort of forecast emulators. But you also have sort of spread maps, right, as well for uncertainty?
Let's see what I have here. Yeah, so I've got a 500, or that was a 200 hectopascal. This is the 500 millibar heights. Again, the same thing, GFS heights, and the colors are AI minus the physics-based.
Right. And so I haven't begun looking at these on a regular basis yet, but Pete's beginning to produce these maps, which are kind of unique. You're not going to find them in other places in the web, but they'll give you a way to begin to assess the differences, the skillfulness of these forecasts.
This is the GFS 850 millibar temperature, and the colors are the same as the other maps on the website for the contours. And the shading is, again, the difference between the AI GFS
Right.
and the physics-based.
So if we stop at just any incident right here, these red areas are where it's warmer and blue's colder.
Yep.
And so this is, what's the time on it? Okay, if we go
48
to,
hours.
let's go to 60. Just curious, and then scroll down a little bit. So 60, this is where we're beginning to see the formation of that thermal ridge at the surface. This indicates, again, we saw the GFS was fairly intense at the surface, and that, from a potential vorticity perspective, looking at the near surface temperatures, having colder temperatures in this thermal ridge right here would suggest a weaker cyclone. So that's one way you could sort of quickly interpret some of these differences here. But you can see the nice thermal ridge that's formed. These are the GFS contours at 850 for temperature. Really nice thermal ridge that's beginning to develop right along the mid-Atlantic coast as that cyclone develops. And then it looks like out over the oceans, the AI models are a little bit too cold, too warm relative to the GFS control. Doesn't mean they're wrong, it just means there's a difference there, something to note. And I think if you look at these maps on a regular basis, you might begin to see some biases in the models.
The other set of maps that I've started working on is they also have the ensemble data for both. Is that right? I think that. Let me think about this. So this is actually just for the AI GFS, and these are 500 millibar, the average of the ensemble. So this is 30, I think, different AI GFS ensemble members all running. They send out the average value, so the ensemble average, and then they send out the standard deviation among those members. So the contours are the ensemble average, and the colors are the standard deviation.
And so again, the higher that standard deviation, the forecast shows you where there's considerable spread in the forecast at that instant in time. If we stop that again at 60 hours on this might be interesting just to see the differences, at least at this level that you're shading things. Okay. At least in this forecast, this is at 60 with the upper trough that we see here. Again, it's smoothed out, so it's not going to look as sharp as what we saw from the single individual forecast, but a lot of forecast uncertainty with this upper trough over the eastern part of the United States. And if we go back in time, can we see if this uncertainty, how it decreases with time? Or at least the source of some of the spread comes from where the models were initialized. So whatever's coming off over the Rockies this morning, this is the beginning of the uncertainty in the forecast and how that upper trough evolves. So that might be a useful thing to go back and see what were the forecast differences at the initial time over the Canadian Rockies. All right. Do you have anything lower at this point yet?
I haven't
Like sea level
got that
pressure?
yet, no.
Okay. But no, I'd like to thank Pete for producing these maps. Again, you're not going to see them, I think, readily in many places yet on the web. So we're kind of beginning to produce tools that people can use to understand the differences between these AI-driven models and the physics-based models that correspond with them.
They're not readily available on our website either. They're sort of in beta, and I can give you the links to where they are if you want, but they're not on the website yet.
Right. So anyway, thanks, Pete, for setting that up. Thanks, Libby, again. Happy birthday, and thank you all. Have a wonderful weekend, and next week we'll talk about what actually did happen along the East Coast this weekend or early next week. This is, I think, going to be an interesting storm to look at. Thank you.
Thank you.